caught up. So really quickly, I'm going to probably just go through and do this instead of making it super. We've done this several times. So the key part of this is you got to know that is the y equals x line of reflection. Diagonal from up to right has a slope of 1. If you remember, like, that's y equals 1x plus 0. So the 0 is where it hits the y axis. However you remember it, that's one of the two I said you got to remember. Really quickly write this in some place where you can make it stand out. There are 4 reflections that have rules and 2 that don't have rules. Really. So the 2 that don't have rules are the ones where it's like y equals a number and x equals a number. So you can just kind of remember the ones where there's like a number involved, they don't have rules. Because the number could be any number, which means we can't really make a rule. Like we can't make a rule if that number changes. So for the 4 that are y-axis, or this is reflection, y-axis, x-axis, y equals x, or y equals negative x. Those 4 all have rules that can be followed. And again, I don't like just trying to memorize rules because that will not last to an EOC. But I do not mind at all. I like if you understand that sometimes if you have a shape that's got even 3 sides, but definitely like 4 sides or 5 sides, which would mean 5 points, because every side's going to have like an intersection of vertices. It might be easier to figure the rule out by moving 1 point and then just go ahead and use the rule on all the other points. So that's what I'm going to show you, that process. Again, you just want to move them all. If that's your process and that makes sense to you, do it. So if I knew I needed to reflect over y equals x, I have my points on the graph. Maybe they give them to you. Maybe they don't give you a graph at all. Like I said, there's all kind of different ways they could ask it. I'm going to pick the easiest point to move. Which one of those is easiest to move, would you say? What color? I would say blue, right? I mean, it's super close. I can very easily count directly at that line of reflection by moving blue. Oh, 1, 2, done. Piece of cake. And I go 1, 2 on the other side. Diagonal can be tricky, but if I'm that close to the line of reflection, not super tricky. Oh, look what it is. I was just thinking, man, that's 2 days in a row. You mean 2 days in a row? Well, 2 days of my class. You weren't here 2 days ago, were you? Oh no, maybe you were. Maybe there was one point where we were trying to figure out. But I think you were in the restroom. Oh, I think you were just in the restroom. We were trying to figure it out. All right, so I've done that. Again, I could try to move all of those points. There might be 4 or 5 points though. They can give you a shape with a bunch more points in triangle. They will. Or I could just say, well, what is that point? What's that new point at? Tiffany, what crap? What's that new point at that I just put on the board? What's the X and the Y? So 1, -3. So I'm going to tell you this story, like the super fast version of it. Delaney, you remember my story about the woman I almost married? Not at all. Justin, that's right. I know. So I make this big. You don't remember this? Maybe you remember. I'll wait till one. I made this big elaborate story up when I used to teach 1A about this woman I was married. I mean, it was like a 15-minute story that I went into. What? See, it got everybody's attention. That's why I did it. Because that was the only way to get. That's the only way to get attention from you guys is to get into my personal life. So I made this big long story up about how we met in this apartment complex, and like I told them all about the apartment complex. But the moral of the story was every time I went anywhere in the complex, the elevators were, and I went like 10 different places in the story. Elevators were at the end of the hallway. But depending on where I was going, she moved a couple times, and there was a gym, and there was a pool, and blah, blah, blah. I would go down to the end of the hall to get to the elevator, and then I would go up or down to get to wherever I was going. So the moral of the story is you go left and right first when you're finding your X value, left or right, then up or down. Because I still have a bunch of kids that for that point will say 3, -1 or -3, 1. No, you got to go to the elevator first before you go down to that point. So the first thing you got to do is get to the elevator. So that's 1. Then you can go down to be -3. But that was the only point of the story. So if you're struggling with that, you've got to know how to put a point on a graph at this point. I can't continue to reteach some of those kind of things. All right, so I could do all the other points, or I could just say, well, if I'm really super confident I did that correctly, what happened? What happened? 9 or something like that. Okay, so they just switch, right? We just switch places. So again, if they, especially if they're asking for the coordinate, you don't have to go. I just bit my cough off, and I wasn't trying to. If they're just asking for the coordinates, just flip all the numbers. So just say, okay, well, if I'm just flipping numbers, that's my new coordinate. That's my new coordinate. I don't have to follow them on the graph if they're not asking me to graph. Again, assuming you feel pretty comfortable that you did the first one correct, which would be the easiest one, so I would hope you would do it correct. Now, I'm still going to show you another thing a student did, which I thought was fantastic. When I've told you, because again, going diagonally can sometimes be a little tricky, especially if there's like a line that's already sort of diagonal. Kids could make mistakes. I said there is a way to do the grid lines, and you kind of make a square, right? You remember that? I went out both ways, and then on the other side we made a square. Did that ring a bell at all? What's true about a square? All of the sides are the same length, right? I never really counted when I did it. I just was visually saying draw them out and then match them up. But one student yesterday, was that this class? That was this class? Yeah. He did this. And I, again, never thought on me to still count but follow grid lines. It was Aiden. Did I hear it? He counted 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Do you do that also? See, I never counted. I just was visually drawing the square because it makes a square. But if it's a square, the side going down will be the same length. So I don't really need the other two sides. I can just count down 12. And that's where it'll go. So you really don't have to make the whole square. You can follow the grid lines. Just remember when you get to the line of reflection, you don't keep going. You have to change your direction when it's y equals x. So it's different than when it's horizontal or vertical, where you just keep going. And this one, you change directions and go down. And I could just test that out diagonally. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Now I'm really sure I can. I could also start by going down. I don't have to go right. I could go down until I hit the line of reflection. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So again, that was open. That's why I don't allow drinks in here. Oh, well. That relation, right? That's fine. All right. So anyway, I don't care how you do it. Do the first one, find the rule out, count diagonally, follow the grid lines, but just make sure you count as you follow the grid lines. Whatever you need to do. I got it. Nothing up there really. All right. So any last questions? We're pretty much done with the reflections. We're moving into rotation. Turn to page 237 in your books if you have your books out. If you don't have your books, we don't really use them. That's mostly for the people that take notes in their book. I can't believe I did that. If you take notes in it, as long as you're taking notes, you've got this stuff, you've got to have these notes down. Mostly, I mean, I don't care if you take them on your graph. That'd be the best place to have them. But you need to make sure you keep this. Too many people leave it or lose it or don't have it. Because what I'm about to give you is the Bible. It is not difficult at all if you follow this process. I'm going to give that. Is there some? Did you ask me first?
Yeah, I asked for it.
Somebody, was that you? Because somebody asked me right when they walked in. All right, go ahead. I couldn't remember who it was. That should be over there. Oh, no, we don't need that. I'm better. I still didn't even put the top on. All right, so in rotations. Yeah. Oh, that's still true. I was gonna say, I was like, that's not my rotation. So here's the overall concept, just quickly. In a rotation, we are not just spinning the image, like we're not just rotating the image where it is. Oh, write this out. All we are doing for a long time, I don't even know if we'll get to anything else. We are rotating around the origin. So everything we do, unless I tell you differently, we happen to get through this stuff faster. Maybe we'll get to something else, or maybe way down the road, like right before the EOC, we might do the other thing, but rotating around the origin. What's the origin? 0, 0, right? We are rotating around the center of the graph. So we're not spinning it right here because that wouldn't rotate around that. We're not rotating around a point like just a random point or even a point that's part of the image. Always around the center of the graph. That's why what I'm going to teach you works, because we're going around the origin. One thing just to keep in mind, though, when I'm rotating, it looks like the image itself is spinning itself, right? It's really not. Like, those eyes are parallel to that edge, right? Well, if I was rotating around, the eyes are still parallel to that edge. So it looks kind of like the image is spinning, but it really just kind of turns as the whole graph turns. So you can kind of keep that in mind, that when you have an image on a graph, whatever point is closest to that edge there and that edge there will still be closest to those edges over there. Like if you turned your head, you could think of this as the top, right? Well, if I turn my head this way and I think of that as the top, my eyes are still going toward the top of the graph. And that's kind of what we do when we actually do it. We don't turn our heads. We actually are going to turn the whole graph when we figure out where it goes. Write these two definitions down. Hopefully you know them, but over them. I don't know why I keep writing those up. Let's save that. So clockwise and counterclockwise. Oh. I don't know why I have that. But yeah, it's different. So I guess I can go ahead and show you this part too. When you're done with that, write these numbers down. While you're doing that, I'll just mention something more for the recording. We talked about the fact that reflections are always over lines. And then rotations have to do with degrees. So if you forget the abbreviations, like we talked about terminology, there's going to be a capital R and a lowercase r. Capital R is reflection, lowercase r is rotation. But if you forget, just know that rotations are always going to be about degrees. We're kind of imagining a circle for rotation. So the little r will always be given in degrees when it tells you what to do. The capital R will give you a line, like x equals 2, or y equals x, or x-axis, or y-axis. So that's how you can tell it's a reflection also, if you forget which one is the capital R and which one is the lowercase. All right, so which way would clockwise be? How would you describe that? Where did I leave off? I don't remember. Fine. You know the answer? I'll go ahead and let you know. So what?
That's right. It's right.
Well, so again, it's hard. Like you can't really use rights and lefts to explain. Best way to do it is say it goes with clockwise. That's why it's called clockwise.
Counterclockwise goes back.
So yeah, so it goes the direction so just watch the second hand. That's clockwise. So sometimes it's going to the right, sometimes it's going down, sometimes it's going left, sometimes it's going up. But that's what it's a circular thing. So you can never say left and right, unless you're just talking about one specific move. So clockwise then is this. Goes around, and again, it's clockwise. Like that's just what it means. I don't know another way to explain clockwise. It goes the same direction, the second hand goes on a clock. So what do you think counterclockwise is? Yeah, it's the opposite of that, right? So counterclockwise would be around the other way. So that's counterclockwise. How many degrees in a circle? 360, right? You've done that before, like that's not new. What would like 90 degrees for a circle be? It's like 1/4. Like so. So now let's just jump to this, see if we get this. And again, if you don't get it, just write it down. It's not a huge conceptual thing you have to get, but you do need to memorize it. How many times, if I wanted this top, so I'm going to turn it's a square, the graph is a square, but I'm going to turn it like, clockwise. How many times would I have to turn it to get to 360 degrees? 4, right? So if you don't understand that, I'm going to do it for you. If I want the top to go all the way back around and be back to the top again, hopefully I can do that for this. Oh, I don't want that. Okay, there we go. So there's one turn. One turn would be like a quarter turn. How many degrees I just turned? That's 90 degrees. One turn. So you may want to write that down if you're not getting it. One turn. So I made the top the right side. That is one turn. That is 90 degrees. 2 turns is 180, and the top is now on the opposite side, the bottom, just like it would be in a circle. Think of a circle. If I start at the top of a circle and go 180 degrees, I'm on the bottom of the circle. If I go 90 degrees on a circle, I'm on the right side of the circle. So 270 degrees would put it, the top would now be on the left. And then if I did 4 turns, I would be right back to my original top. So that little circle was always representing the top as I went around. So 1 turn, 90 degrees. 2 turns, 180. 3 turns, 270. And then I doubt you ever see one with 360, but I think I actually did see one over 360. So you had to like go around once and then a little bit more. But that's pretty rare. All right. So here's the only last piece. I'm going to tell you to rotate an image. And this is actually something where we do the whole image at once. Like for the reflections, we do it one point at a time. In a rotation, you can actually do the whole image at once. You can do individual points as well, but it's easier to do the whole image. You just have to know which direction you're turning the graph and how far you're turning. And then and that's the easy part. Here's the part that some kids, again, like I said, some kids think it's the easiest thing ever, and some kids are just struggling on this one thing. I don't know how else to say it. You have to ignore the numbers on your graphs. So look at your graph with nothing on it. It has numbers on it, right? Those numbers are going to move because we're going to physically turn the paper. But that doesn't mean that you're changing the way a graph works. Like, what are the values? I wish I had a blank graph. What are the values that are to the right of 0 for the x? Like they are what? They're all positive, right? They will always be positive. The values to the right of 0, 0 are positive. What are the values above 0, 0? Positive. What are the values left of 0, 0? Negative. What are the values below 0, 0? Negative also, right? That never, I don't care what your paper says. You're going to be turning your paper. Ignore the numbers when they turn. You got to know this is always the positive x. I mean, think of a number line. Those are always the positive x values. The y-axis will be sometimes here. Like it'll say y. Doesn't matter. You're thinking of it as if it's just a normal graph. The x-axis, positive, negative. The y-axis, positive, negative. All right, if you can just pick that up, it's the easiest thing in the world.
So it doesn't find out what type of graph.
Well, we're going to do one. So let's just go ahead and do one. So first, put these points on the graph. These are the 3 points. Should look kind of like that. Now it should look exactly like mine because your graph should be going to 10. So on the other ones, it was like all the way to the edge if you were here the other day. So put these 3 points. I'm going to zoom in a little bit. Sort of a lot. I'll zoom back out, but just so you can see what the points are, I'll zoom in. So don't do anything else. Put the points on the graph. Yeah, did you have?
Yes.
Yeah, you would say. I would get farther this password for you. And this is easier if you just have one graph and not 4 on a page, but it's not that bad. Really, yeah, you need to see the next things we do. Just hang in there. Just hang in there. Like shouldn't be more than this. Hopefully, if people get it right. So I've kind of written in the number. I don't have numbers on this, but you see, actually, while you're doing that, I'll do these two. That's kind of more what yours looks like. All right, so I want to, so just follow along. Don't do anything yet. Watch what I do. I think I jumped too far ahead and tried to have them do it. I'm just going to do it. I want to rotate that 90 degrees counterclockwise. So let's first talk about how many times I turn in which direction. I don't remember where I left off. We'll go with Trevor. How many turns is 90 degrees, we said? I'm going to turn once. Elijah, what direction? Just show me with your hands. What's counterclockwise? So it's the opposite. I can't even tell what you're doing. To tell you the truth, I'm backwards from you, but it's the opposite, right? If the second hand goes that way, I need to go that way. So I am going to physically. So don't do anything. Watch what I do. Kids kept trying to go ahead. That was another problem. I'm going to physically take my graph. Well, I need to do one thing. Hold that thought. Hopefully this works. Okay. I'm going to take my paper for you. Don't do it. Do not do it. And I'm going to turn my paper. Oh, apparently I don't have a pen now. I'm going to take it. I'm going to twist it, turn it, whatever you want to call it. One turn left. So the top is now the left. Because that's the direction I'm going, right? I just turned it once counterclockwise. Now, the image will move. So you got to imagine the image is still up there. These 3 points were still at negative. So again, ignore the numbers. I don't care that these positive are up here. More so, I don't care that these positive are now showing positive. This is still the negative x part of the number line. This is still your x-axis. I don't care that it says x up there. That is still that's the way a graph works. The top is the y. That's the positive y's, negative y's, positive x's, negative x's. Doesn't matter where my numbers went. I do not use those. I just got to know that's 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And then I got to know where all the other ones are positive and negative. So I'm going to wind up counting to figure out the next step. Oh, so I was going to put them in just really quickly. So you got to know the original image. It won't be there anymore, but it's still the original image. So it would still be there. -5 and 7 and -7 and 4. So that's where our image was right there. This is where the new image will be. Like that's exactly where the new image is. When I rotate the whole graph, because it's around the origin, that's how a rotation around the origin works. Those are my 3 new points right there. So I just say, okay, well, I'm just going to write those 3 new points. Again, this is not +1. That's the negative part of the x-axis. This point right here is at -1, -3. I don't care what the numbers say because I move the numbers, but that's not how a graph works. So now I do that for everyone. This is at -7, -1, 2, 3, 4, 5. So the red is -7, -5. And then the green would be at -4, -7. That's your 3 new points right there. So you would just, again, if that's all they ask you for, if they just said, what are the 3 coordinates for the final image, or they would just say pre-image and image, but if they say, what are the 3 new coordinates, whatever the terminology is, that's them. If they say graph it, you would write those down. Well, actually, you'd have to do this on graph paper. So if it's the EOC, you would just do it on graph paper. Then you'd go up to your computer and put them in. So you'd have to take whatever's on the screen, put it on graph paper, do this, and then put it back on the computer. But that's it. All you gotta do. We can tell rules. So every rotation has a rule. What's my rule? I want you guys to try to figure it out for now. So look at what happened. The blue ones are right next to each other. Well, they're all right next to each other. See if you can figure out the rule. Don't say it out loud. I want everybody to be thinking about it. So see what happened. Where did my X go? Where did my Y go? What did anything flip signs? And they should all do the same thing. So if only some of them do it and the others don't, it's on their own. Oh, I got to call on for that. Tyree for this one. You know Tyree? You got it yet? What do you mean by flip? Let's be specific. So switch, because again, sometimes we say flip for sign, sometimes we say flip for change places. So let's be specific when we say it. So it switched places. It was in the back, and it went to the front, and it changed sign. Just know that it's depends on how it starts. We don't always want to say it goes negative. So the rule would be my original point, the Y moved to the front and flip sign. The X just moved to the back, right? The X didn't flip signs. So we just write the X. So that's how, just like we did with the reflections, that's how you can figure the rule out if it's a question about rules, not just do this rotation. All right, so again, all you got to know, which direction are you turning your graph? How many turns? And then just ignore the numbers. Just make sure you understand this is always positive x's, negative x's. That is always positive y's, negative y's, and then just count to figure out where the new points are on your graph and write those down. And that, I want to say normally that's what they ask you for. They may ask you to graph it, but I think it's more likely they just ask you to put the coordinates in. All right, raise your hand if you got it. That's not horrible. I'm going to walk around. If you got it, no need to call me over. If you don't got it, call me over. I want you to rotate this one. So again, start with the same points. Try to just make it consistent. So faster to graph. Do it on a different graph, though. Don't try to use the same graph you just used. Do it. I gave you a bunch of graph paper. I have more if you need it. Put those 3 points on the graph, and I want you to rotate at 180 degrees. And then I want you, if you get done with that, you're pretty confident, try to find the rule. There's a different rule for that. None of the rules are the same. It's always a different rule.
Clockwise and counterclockwise.
It's a great. Did everybody hear that question? And you asked it. I normally count. I didn't get a chance to start counting before somebody asked me that. Doesn't matter. Because where is it? Where is 2 turns going to wind up if I go to the right? Well, across from it, right? If I turn right, I'm going to go here and then here. Well, where am I going to wind up if I turn left? Here and then here, right? Same. It's always the same thing. So they will not typically give you a direction when it's 180 degrees because it's the same. It doesn't matter which way you go. If they do, then you can go that way. But 180 degrees clockwise is the same thing as 180 degrees counterclockwise. Yeah, I mean, I'm going to wind up spinning it so I can show it. Well, just do it and I'll do it the opposite way you do it. So spin it whichever way you want. You go clockwise if you want to go clockwise, and I'll do mine counterclockwise, and you'll see it's in the same spot. Yeah, I mean, you work together. Like if you're struggling, I guarantee you somebody around you got it down. So don't sit there and struggle when there's people around you that are getting it. Did you do it already? I'm going to look at it while you're gone. It better be right. Do you feel any pressure? Oh, all right. That's not see that even up there. Either. Oh, or maybe that. Oh, I can't tell. Maybe this. Got you. Okay. Oh, write down the new ordered pairs. Because I want you to find the rule. I want to practice finding the rules also. So once you turned it, you need to write down what those ordered pairs were. She didn't do that. She just drew it. So do both. Draw it in. I mean, you got to it's easier to write the ordered pairs first anyway, and then draw it in using those new ordered pairs. If you're really visual, I guess you can do it the other way. But give you another minute. What really makes it easy is you've got 2 of them, like the picture does with tracing paper, and he like would say, so we'll go like trace. So he traces this, like if you put it through the light, he's not really actual six numbers, and then he rotates this twice, so you can still see the 1 image, and you can't see the rear images, and that's. No, I don't. I'm not disrespecting. It's 3 times 3 negative. Which one is the one that's 0 Alex? Well, yeah, that way. So if I turn it here, 3. Where's that fucking get? More of the numbers, just the normal graph. The positive x's, positive y's. Try to do. Oh, the original was negative. This is negative. Something. Well, again, you just write the new value. I'm not sure exactly what you're saying. Once you turn it, that's where it is. That's where the new image will be. Just write the ordered pairs for all of those points. I'm going to do it up here. So just try to follow along. Yeah, if you think you got it, let me raise your hand. Let me see. No, it's not a flip. You're doing 180 would be two turns. One, I'm not even sure. Oh, you started. Yes. So 180 would be one turn, not two turns. Fine. Right. You're right. Sure. So again, a lot of us are still struggling a little bit with this. So I'm going to go over this one and then that looks good there. I know, well, at least I know that one is and everything else is there. No idea? All right, if you're not getting it, I'm going to do another one. So again, I don't know of another way to teach this. I really don't. I mean, I can have you memorize rules, but that definitely won't last till the UFC. When I rotate it, that again, if you have the points already on there, not much to do. You don't have them, put them on the graph. Hopefully you're all putting them on the graph. Joseph, put that up, please. I'm already a little frustrated. I want to see somebody on the phone, especially if I walk over and you don't have this right. I take the whole graph. How many turns is 180 degrees? 2. I've turned it twice. The top will be at the bottom. Like if I turn it twice, the top's going to wind up being on the bottom. 1, 2. Ignore the numbers. The numbers just moved. These were positive, and now you're going to see positive down here. But you should know that's not the way a graph works. The bottom part of a graph is negative numbers. These are negative. These are positive. These are negative. I don't care where your numbers went. You know how a graph works. You should know the quadrants. 1, 2, 3, 4, 5. They're just number lines. 1, 2, 3, 4, 5. Negative 1, 2, 3, negative, negative. Negative, negative, negative. So now if you understand that, you just write these points down. So what is the blue point at? Where am I at? I don't really know where I'm at. Sage, what's the blue point at? I just 1, 2, 3, negative 1. So my blue point goes to that. I just write exactly what points I'm looking at as if it was a normal graph. So the red point would be 5, negative 7. The green point would be 7, negative 4. You just write the points from the image that you rotate. If that's all they ask for is what are the coordinates, then that's your answer. You're done. If they tell you to graph it, then you go to the computer and you put those points on the graph on the computer. I'm talking about the EOC. On my test, you'd have to like turn the paper back, say, okay, well now I need to graph it. So you'd have to turn your paper back on my test to say, okay, well I know those are the new coordinates. Now let me graph it. So you'll turn your paper back to where the top is back to the top. And now you just put those new points in that quadrant. So you'd plot 3, negative 1 goes there. I'm not going to change colors. 5, negative 7 goes there. And what's the other one? 7, negative 4 goes there. So you just redraw them in where it was a minute ago. I mean, if you want to try to memorize all the rules, there are rules on your, like in that chapter where I just said page 237. I think they're right on the first page. But I'm not sure we're going to keep those straight even on my quiz, especially when you also have reflections and all that stuff on the same quiz. Again, the people that get it can immediately, it's easy. That's why I don't want to change it. I looked at yours. Yeah, I'm sorry. Oh, yeah, I looked at yours. It was good. Just make sure you write the points down, like the new points, but they were all in the right spots. I'll try to think if there's something else we can do to make it stick. I mean, basically, practice is what's going to make it stick. Yes, the people that get it. But some people like, I don't know if it's I don't know if it's a visual thing. Stop that recording. So how did you feel on that, Kane? Do you think you were starting to get it or not?
Still struggling.
There's an IXL in there on rotation, so you can always do the IXL, which I'll give you guys. I meant to give it to you, but so many people are struggling that I didn't really worry about it. So, but yeah, we aren't going to be able to spend a whole lot more time on it because we got to. That was all. They only gave us one day on that.